Physical change. A substance is usually identified by its physical properties, by its shape, size, color, state, etc. We know that water is wet and gold is shiny. That is how we identify them. When there is a change in any of the physical properties of a substance, its shape, size, color, or state changes. This type of change is called a physical change. No new substance is formed in this type of change. It is usually reversible.
Take a piece of paper and crumple it. What happens to the paper? The original shape of the paper changes because you have changed the body of the substance without changing its composition. You have only changed the appearance but not the composition of the paper. So, you have not made a chemical change but a physical change. Take chalk and crush a small piece of chalk into dust. Add a little water to the dust to make a paste. Roll it into the shape of a piece of chalk. Let it dry. Did you recover chalk from the dust? Yes, you will obtain the chalk. This kind of change is a physical change. Take some ice in a glass or plastic tumbler. Melt a small portion of ice by placing the tumbler in the sun. You have now a mixture of ice and water. Now, place the tumbler in a freezing mixture, ice plus common salt. Does the water become solid ice once again? Yes. Water changes to ice on cooling in freezer. Take some ice cubes out of the freezer and put them in a beaker. Leave the beaker for some time. What would you observe? The ice would turn into water. That is, the state of the matter would change. You want to inhale steam. As you have a cold, you would still have the remaining half measure of water. Pour the remaining water into a suitable vessel and put it on a lighted gas stove. The water would start turning into steam. That is, the state of the matter would change again. Thus, you would thrice have changed the state of water, only to find that it was a physical change and hence reversible.
Understanding chemical change. A chemical change is a process in which substances are changed. Chemical change occurs whenever compounds are either formed or decomposed. During a chemical change, a chemical reaction takes place. A chemical change is permanent and is therefore irreversible. For example, burning a log of wood. It turns into ash, and the resultant ash cannot be changed back into log of wood.
Take a piece of magnesium ribbon and burn it over a flame. The magnesium ribbon burns with a brilliant white light. You will notice a white powdery ash left behind when the magnesium ribbon is completely burnt. Collect the white ash and drop it into a beaker containing 30 ml of water. Stir the water thoroughly and test it with litmus paper. It turns red litmus into blue, while blue litmus does not change the color. You can conclude that magnesium on burning in air forms a new product, that is, magnesium oxide. The change proceeds with the evolution of heat and light. The change is permanent and irreversible. The magnesium oxide is added to another chemical reaction, forming magnesium hydroxide, which is basic in character. A beaker is half filled with water. A teaspoon full of copper sulfate is added to it. A few drops of sulfuric acid are now added to the solution. Do you notice that a blue-colored solution is formed? The solution is divided into two parts and is kept in two beakers. Iron nail is dropped into one of the beakers. Wait for half an hour or so. What do you observe? Now compare the color of the solution kept aside in the other beaker with the color now formed in the solution. Do you notice any change in the nail after it is taken out of the beaker? A brown color of copper deposit on the nail while the color of the solution is changed into green. This is an example of chemical change. Let us observe another reaction to see a chemical change taking place. 1 tablespoon of baking soda is added into 100 milliliter of water into a beaker. It is stirred well till all the baking soda is dissolved. 5 milliliter vinegar is then taken in a test tube. With the help of a dropper, a drop of vinegar is put on a strip of red and blue litmus paper. Now, add at least 5 drops of baking soda solution to the test tube containing vinegar. Bubbles are seen to have formed due to evolution of carbon dioxide. The mixture is stirred till the bubbles stop. Again, test the solution with red and blue litmus paper strips. Since vinegar is acidic, it turns blue litmus red. When baking soda is added to it, the new solution does not affect any change of color in any litmus paper because it has become neutral in nature. The vinegar, acid, neutralizes the baking soda, base. Hence, this type of reaction is known as a neutralization reaction.
Let us study the difference between physical and chemical changes.
Rusting. Rusting is actually corrosion. Corrosion is the reaction between a material and its environment which causes the material to deteriorate and alters its physical properties.
Take water in beaker and add a few drops of dilute sulfuric acid H2SO4 to it before putting it to boil. When the solution starts boiling, add powdered copper sulfate and keep stirring it. Make a saturated solution. Keep on adding copper sulfate till no more of it can be dissolved. Filter the solution and let it cool. Leave it undisturbed while it cools. What do you observe now? Crystals of copper sulfate are clearly visible.
Covered in this lesson are Introduction, Physical change examples, Chemical change examples, Rusting of iron, and Crystallization. So what comes to your mind when you think of change? When you go to a parlor, get a haircut. That's a change, right? Because your look gets changed, your hairstyle gets changed. So haircut is a change. You have a piece of paper and you tear it into 2 pieces. What happens? It changed. Initially it was just 1 piece of paper which was kind of rectangular in shape, but now it is like 2 different pieces of 2 haphazard shapes. So this is a change. You have a piece of paper and you just burn it. What happens? Initially you had a paper and now what do you have? You do not have the paper at all. Instead you have ashes. So that's a change. You have chocolate, the dairy milk, maybe your favorite one. Now instead of keeping it inside the refrigerator, you just kept it outside, and it was so hot that day, and what happened? The chocolate melted. Now once the chocolate starts melting, what happens? It's no more the same bar of dairy milk. So it kind of changed, its shape changed, its size changed. So that is also a change. You have an egg. You didn't feel like having the egg, so you just prepared an omelette. So where's the egg now? The egg is no more there. The spherical egg is gone. It is changed into an omelette, which has a different shape, which has a different composition, which tastes different. So this is again a change. So all these things which I'm talking about, so what are these? I mean, what is change in that case? So change is nothing but anything that becomes different undergoes a change. So different is the word that defines change. So anything that looks different. So when we go for a haircut, so the look is different. So the hairstyle is different. That's why it is a change. When I tear a piece of paper, so now the torn pieces, they look different from the original single piece of paper. So that is why it is a change. When I burn a piece of paper, I do not have the paper anymore. Instead, I have ashes. So the ashes are different from the paper. So this is again a change. So anything which becomes different, so that is nothing but a change. Now in our day-to-day life, we encounter a lot of changes around us. We see a lot of things changing. So here in this lesson, we are going to talk about such changes. So these changes can also be understood from the perspective of science. So there is always science involved behind everything. So many things which appeared magical to you, but actually there is some science behind it. So gradually, as you learn more science, you'll get to understand more of the physical phenomenon that happens around you, more of the various scientific things taking place inside our body. So we get to know all about that. So here we will talk about various types of change. So let's look at this example which is given on the screen. So what do we see here? We see here a piece of paper, and how does it look? It looks like a rectangular sheet with something written over it, white in color. So that's how its shape, size, appearance, texture is. Now when I burn this paper, what happens? What I get? I get ashes. So now in any way, do you think that the ashes look similar to the paper? No way. Ashes, they are like powder. They are some grayish black in color. So their shape, size, color, texture, everything is different from the paper which we had earlier. So just burning the paper, so burning, the process of burning actually changed one object to another. So this is a change. So this is an example of a change. Now, there can be many different types of changes. Now, some changes can cause a change in shape. Some changes can cause a change in size. For example, if you look at this torn pieces of paper, what do you see? So, initially it was just one piece of paper which was quite bigger in size. Now that it has been torn into pieces, you have more pieces of paper, but each of them is like quite smaller when compared to the initial single piece of paper. So, there is a change in size here. Not only size, in fact the shape has also changed. If you look at this melting chocolate, so here also you see that there is a change in shape. There is a change in the texture. So initially it was quite solid bar, but now it is like semi-liquid. One of the best example that you can consider is ice, water and water vapor. You take some water in a bowl. When you start heating the water, after some time what happens? You see that the water starts getting converted into water vapor. So that is again a change. Initially we had the water in liquid form. It was liquid, fluid. But now it is water vapor, which is in gaseous form. So the form changed. Similarly, if you start freezing the water, what do you get? You get ice. So this ice, water and water vapor, these are three different forms, even though all of them are H2O. So their chemical composition, chemically each of them is H2O, but this is solid, this is liquid and this one is gas. So their states are different. So a change in state happened when you altered the temperature. When you start heating water, it changes to gaseous state. When you start freezing water, it changes to the solid state. So this is again a beautiful example of change. So when I talk about change, it is not necessary that there has to be a change in size only. It can be size, it can be shape, it can be texture, it can be the chemical composition, it can be the state. For example, in case of water. Now, let's look at another example. Let us suppose you have a beaker and inside that beaker you have a solution which is copper sulfate solution. So this is, let us say, copper sulfate solution, which is kind of blue in color, bluish color, copper sulfate solution. Now, in this copper sulfate solution, we put some magnesium powder. So let's see, this is some magnesium powder. What do you see? What do you notice after some time? You see that after some time, the solution starts fading in color. So the solution gradually turns colorless or white. Do you know why? Because this magnesium starts reacting with the copper sulfate. And when it reacts with copper sulfate, what happens? Magnesium reacts with copper sulfate to form magnesium sulfate and copper. So this copper which is being formed, this will start changing the color of this white magnesium powder into blue, and this magnesium sulfate will start changing the color of the copper sulfate solution from blue to white. So what is this? This is again a change. But in this kind of change, you see, there is no change in size, there is no change in shape, there is no change in texture also. But what is the change here? There is a change in the chemical composition. Initially, the fluid was copper sulfate. Now the fluid is magnesium sulfate. So there is a change in the chemical composition. There is a change which has taken place internally. So the change can happen in a lot of different ways. So in this lesson, we are going to learn about the different types of changes and how do we classify that which change is what type of change. Now, based on all these examples we have seen so far, so we can see that changes can happen in a variety of ways. Now, thank you. Please visit www.examfear.com to watch more educational videos with a better experience. Please do not forget to like and subscribe to our YouTube channel for latest updates. Thank you once again. To discuss. One is a physical change and the other one is a chemical change. So let's see what is physical change and what is chemical change. So we will start our discussion with physical change. Now, as the name suggests, the change is with respect to the physical properties. So when the change is such that the differences are noticed with respect to physical properties. What do you mean by physical properties? Those properties which can be observed, which can be measured, which can be seen from outside. They are called physical properties. So let me give you some examples of physical properties. For example, color, shape, size, appearance, texture, smell, melting point, boiling point. So these are all physical properties because you can actually see them or you can actually measure them from outside. So they are not internal properties. So they are all external. So these kind of properties, when there are changes in these physical properties, the change is said to be a physical change. Now, mostly the physical changes are reversible change. Reversible, something which can be reversed. So that means the change has taken place and again the change can come back. So let's take an example, a very simple example of your haircut. So hair is a physical property. It is something which can be seen from outside. The length of the hair can be measured from outside. So it is a physical property. So when you go for a haircut, what happens? The size and the shape of the hair changes. So it is a physical change. Now, do you think that it can be reverted back? Yes, of course, because your hair will again grow. So again your hair will grow and again you can go for a haircut. Right? So basically these kind of changes, they are physical changes. Let me give you an example. Let us suppose you take the example of water. So water, ice and water vapor. So all of these, if you look at their chemical composition, all of them is nothing but H2O. This is also H2O, this is also H2O, this is also H2O. But there is a change that is happening. Why is that change happening? Due to difference in their physical properties. So if you look at ice, ice is solid. The appearance of the ice is very much different from the appearance of the water, which is liquid. Again, the appearance of the vapor, which is a gas, is a lot different from solid and liquid. So due to these changes in physical properties, this change has taken place. But the chemical composition still remains the same. So this is an example of a physical change. So we are now going to discuss about some more examples of physical change. So the first example we will take is breaking of a glass. If a glass breaks, what happens? What changes? The shape of the glass changes, of course. Initially it was one complete glass. Now it is like broken pieces of glass of different shapes and sizes. So the size changes, shape changes. What else changes? The texture, the appearance also changes. But do you think that because of this change, a new substance is being formed? Chemically, whatever glass was, the same chemical composition remains even after breaking into pieces. So there is no change in the chemical composition. Just the size and shape of the glass alters. So therefore, this is a physical change. Now you might ask that once the glass breaks, I cannot join it to form the same glass. Yes, you can. If you become a little more imaginative, you can actually think how the small pieces of glasses can be used to make a new glass. It can be used. Maybe you cannot do it instantly, but it is not impossible. It is possible. Maybe if you take small pieces of glass, in fact, that is how all the glass objects are being manufactured in the factories, with pieces of glass molded together. So, of course, it is reversible as well. So, this is an example of physical change. Again, if you take example of a paper being cut into pieces, so just think of this newspaper and just think that you have cut this newspaper and torn it into pieces. So what do you think changes in this case? Initially it was just one single rectangular piece of paper. Now it is like multiple pieces, each of different shapes. So the shape has altered, the size has altered, but again the chemical composition of paper is still the same. No new substance, no new chemical substance has formed. So this is again an example of a physical change. Think of breaking an egg. Now please note that here I am talking about breaking an egg. So we are just breaking the egg. So when we break the egg, we are not altering the chemical composition of the egg. So the egg is still remaining the same. There is no change in its composition. It's just that the size changes, the shape changes, the appearance changes. So in fact, you can even think of restoring the same egg with a little more imagination, thinking that you will just join all the pieces together. So this is again a physical change. Think of chopping a log of wood. So when you're chopping the wood, log of wood, what happens? The size changes, of course, because you are actually breaking it. So you see, it is actually coming out in small pieces. So size, shape, appearance, they are changing, but again the composition remains the same. So whether to determine if a change is a physical change or a chemical change, one important trick is that if any new substance with new chemical composition is being formed, that means definitely it is a chemical change. But as long as no new substance is formed, it is always a physical change. And if you observe more carefully, you will see that all physical changes are mostly reversible. So you can actually revert them to get back to the original substance in some or the other way. Think of a mixture of water and sugar. So when you mix sugar with water, what happens? So you get a sugar solution because sugar is highly soluble in water. So it easily dissolves in water. So you get a solution. But do you think that chemically a new substance is being formed? Now initially also it was sugar, it was water. So chemically it was H2O. And chemically what was sugar? Maybe let's say it is C6H12O6 or whatever. Now even after you mix both of them, they do not react with each other to form a new substance. It is just a mixture of the two substances, but they are chemically still the same. So no new chemical substance is being formed. And moreover, if you want, you can separate it as well. Sugar and water, even though they dissolve with each other, but there are so many processes by which you can also separate them. Not only sugar solution, if you think of a solution like salt and water, if you mix salt with water, then also you will get a salt solution, that is NaCl, when mixed with water. So there also they do not really react with each other. If you start boiling the salt water, what happens? The water will evaporate and you will be left over with the salt. So you can actually separate water and salt. So it is again a reversible process. So this is again a physical change. So when you mix these kind of substances which mix together to form a solution, but actually chemically they are still remaining the same. They are not forming a new chemical substance. And moreover, they are also reversible changes. So this is also a physical change. Thank you. Please visit www.examfear.com to watch more educational videos with a better experience. Please do not forget to like and subscribe to our YouTube channel for latest updates. Thank you once again.